Bismillahirrahmanirrahim. Students, welcome to a virtual session of week 7 of databases, introduction to databases course. So we were talking about normalization in this week, and we are going to see normalization further in today's virtual session as well. If you can hear me properly, please raise your hand so that I can continue. Okay, thank you, Fatma. Okay, so we talked about normalization. And we talked about first normal form, second normal form, and third normal form of normalization so far. So we have to talk about another normalization form, which is BCNF. So we'll be talking about that as well today. So first I'll review the lecture which I gave in my face-to-face class, and if you have any questions you can ask me from there, and then I'll continue with the BCNF, and then I'll be giving you sample question or an example question from normalization, which will be for your practice, and you should be able to solve that, and you can test that whether you have understood certain topics or not. So let's start from this. And I have just uploaded these slides, supporting slides of week 7, which I've used and are on the Blackboard as well. So normalization is the process of removing redundant data from your tables to improve storage efficiency, data integrity, and stability. So to quantify that how efficient your database is, you use normal forms, and these are the algorithms for converting there are algorithms for converting a database between them. So I'll be skipping these because you've already talked about these. So there are different normal forms, like first normal form, second and third normal forms, and if we have converted our database up till third normal form, it is considered sufficient for most of the applications. So normalization is basically the process which improves your databases, and the objective of normalization is to create relations where every dependency is on the key, the whole key, and nothing but the key. So the dependency should only be on the primary key. So the first normal is considered the weakest, second is stronger than 1F, third is more stronger than 2NF, and BCNF is considered the strongest one. So if any relation is in BCNF, it means it is in NF, 2NF, and 1NF as well. Because it works like this, like if your database is in 3NF, so it is already in 2NF and 1NF. So it appears like this. Then we study the example of normalization. So I won't be repeating this, but I would like to know if you have any question from this example. Can you see the link? Can you see the web link I just opened or not? Can you see it now? Okay, then I think I need to first close my slides, then you'd be able to Can you see it now? Okay. So we talked about normalization, and we started an example that if your database is not normalized, then you can have certain problems. So you convert your database to remove all the insertion, deletion, and updation anomalies. And we talked about first normal form, second normal form, and third normal form. And in first normal form, I told you that as per first normal form, your no two rows of data must contain repeating groups of information, and each column should have must have a unique value. For example, over here you had student column, age column, and subject column, and under the subject column you were recording two subjects for the student. So you cannot record two values in a single column. So you need to remove this, and how you resolve this is by having two separate columns for that student, one with the subject biology, the other with the subject math. So if there are some repeating values, or there are some multiple values in for any one of the attribute for a entity instance, you need to split in two different rows. So when you are, what happens is when you use the first normal form, data redundancy increases. So there will be many columns with the same data in multiple rows, but each row as a whole will be unique. So now each row is unique. It is in first normal form. Now the second normal form suggests that there must not be any partial dependency of any column on the primary key. The partial dependency means that if a table has a concatenated primary key, concatenated means a primary key made up of multiple keys. So then if there is such a primary key, then each column in the table that is not part of the primary key must depend upon the entire concatenated key for its existence. It should not depend on one part of the primary key. If this is the case, that there is a key in your table which is depending on part of your primary key but not on complete primary key, then it means that your table or your database is not in second normal form. Now how you resolve this? This can be resolved if you divide your table into multiple tables. And how you do so? For example, if you see the same table, you can see that in the above table, the primary key of this table is student plus subject. Student and subject are combinedly making up your primary key. So now this age attribute is depending on student only, not on subject. So it means there is an attribute in your table which is not a candidate key. So I hope you understand that what is candidate key. So a candidate key is the one which was not selected as a primary key, but is also unique. You can also uniquely identify the different instances of different entities of your entity set. So now this age is not a candidate key, but it is depending on only one part of your primary key, that is student. So how you can resolve this? You can resolve this by having two separate tables, one for student and one for subject. In one table you are mentioning student and age, in the other you are mentioning student and subject. Now in the subject table, the candidate key will be student subject column. Now both of the above table qualifies for second normal form and will never suffer from update anomalies. So there are few complex cases in which the second normal form still suffers from updation anomalies. Now let's come to third normal form. In this third normal form, where it says, what the third normal form says, that every non-prime attribute of the table must be dependent on the primary key. So it should not be dependent on some other primary key, and if it is the case, then it is called transitive functional dependency. For example, in this table of student, there are details like student ID, name, date of birth, street, city, state, and zip. Now these three attributes, street, city and state, are dependent on this zip code but not on student ID. So to resolve this, what we should do is that we should make a separate address table containing zip as the primary key, and this is used as a foreign key in our student table as well, because this was the information associated with student. So you can remove it by splitting your tables into multiple tables and separating the information which is depending on some other key. So you have removed transitive dependency. So now amount of data duplication is reduced and data integrity is achieved. So I want to know if you have any question or any problem with in understanding these examples of first, second and third normal form. So is it clear? Is there any, if you have any question, any type of question from these, you can ask me now. Okay, Amal, anyone else has any question? If it is clear to you, then it's very good, because this is the very basic information about this. Okay, that's good. That's very nice. Okay, now let's move to the other example to make it more clear. Now the example 2 is about this one. Now in this table you can see that there are two books about which the data is stored. The first book is Database System Concepts. The second one is Operating System Concepts. The first author of both of these books is same. The second author of both of these books is also same. The ISBN of both of these books is different, and the subject of Database Systems Concepts book is MySQL and computers, and Operating System Concept is under the computer subject. The pages are, number of pages are mentioned over here, and the publishers are mentioned over here. Now, I hope you have seen this table clearly now. So is it clear? Okay. Now, this table is not very efficient with storage. Now, if you see this table, and if we talk about first normal form, what problems can you see in this table? If we talk about first normal form, what are the problems you can see here? No, it's not a problem that they have one writer. I'm talking about first normal form, that under a single column there should not be more than one attribute values recorded. Here you can see under the subject column that you have recorded two subjects in one space. So there's MySQL, there's computer. So it means there should be separate columns, one with MySQL and the other with computers. So this is one problem which I can see here. Okay, now let's see some other problems. We have two violations of first normal form. First, we have more than one author field. So this is also a violation, because you cannot say that like author 1, author 2, there can be books with 3 authors, or there can be book with one author only. So if you are keeping it as author 1, author 2, so it means you are keeping information in some non-consistent way. So you should have a single column for author, and you should record it in this way that if there is some author 2, then you can record it for author 2 as well. Repeat the information but with the name of author as author 2 name. Second, our subject field contains more than one piece of information with more than one values in a single field. It would be very difficult to search for all books on a given subject. So this is the problem, which is now resolved. What you have done is that instead of making different columns for author 1, author 2, you have made a single author column in which you have mentioned the book name once with the Abraham Silber Shorts, and then with the Henry F. Korth. And then you have mentioned subjects differently as well, once with MySQL and once with computers as well. So now you have resolved this problem up to some extent. We now have 2 rows for a single book. Additionally, we would be violating the second normal form. A better solution to a problem will be to separate the data into separate tables. So the problem is now that we are duplicating information, like we are keeping information multiple number of times for the same book. So what you can do is we can have a solution in which we make 2 tables, an author table and subject table, to store our information and removing that information from the book table. So what you can do is that you can make a book table with ISBN, title, pages, and publisher, and you can make a subject table with subject IDs like subject and MySQL computers, and you can make an author table with author, first name, and last name. So now you are keeping all the information separately. Now each table has a primary key. You can see here that subject ID is the primary key of subject table, author ID is the primary key of author table, and ISBN, because it is unique, so it is primary key of book table. Now each table has a primary key which is used for joining tables together. When querying the data, a primary key value must be unique within the table. No 2 books can have the same ISBN number, and the primary key is also an index which speeds up data retrieval based on the primary key. Now we need to define relationship between the tables. So since we have to link these, and we have to link these, we need to define relationships as well. So to link them, what we do is we want to link author and book, and we want to link book and subject. So you can do it like this, like we can record ISBN and author ID in this way, and ISBN and subject ID in this way, and we can now these tables are now representing relationships. So you can represent relationships in other tables. So now it's not a problem that we are splitting one table into multiple tables. So it makes our database more efficient. As per the first normal form deals with the redundancy of data across the horizontal row, the second normal form deals with the redundancy of data in the vertical columns. So normal forms are progressive, so to achieve second normal form, the table must already be in first normal form. So you cannot do it that your table is not in first normal form and you start looking for second normal form. No, you first have to make it in first normal form, only then you can go for second normal form. Then you can make another table for publisher as well. Like for right now you have a single publisher, but if you have multiple publishers, then you can make a table like publisher ID and publisher name, and you can record publisher ID in book table like this. Now here we have one-to-many relationship between book and publishers. A book has only one publisher, and publisher will publish many books. Where we have one-to-many relationship, we place a foreign key in the book table pointing to the primary key of the publisher table. Now remember this. This is very important point, that whenever you have a one-to-many relationship, then what you have to do is you have to place a foreign key on the many side, because one publisher can publish many books. So on the many side, you have to place the foreign key of the other side. So what you can do, you have done is you have placed the publisher ID in book table over here, because there was one-to-many relationship from publisher to book. One publisher can publish many books, but one book can be published by one publisher only. So keep it in mind that whenever there is a one-to-many relationship, what you have to do is you have to place the primary key of one side on the many side. Now, the other requirement for second normal form is that you cannot have any data in the table with a composite key that does not relate to all portions of the composite key. Now, let's talk about third normal form, which requires that there are no functional dependency of non-key attributes. Non-key attributes means the attributes which are not candidate keys on something other than a candidate key. A table is in tree and F if all of the non-primary key attributes are mutually independent. They are not depending on someone else. So there should not be, and if they are depending, it is called transitive dependency. And if it is not there, then we can say that there is no transitive dependency. So now let's stop here and move to the next part. So if you have questions so far from these contents, you can ask me. Is it clear? Okay. So let's move to the other part. The normal forms 3NF and BCNF. I'm going to skip these because, okay, you need to remember these, that these are the benefits of normalization. This is the same first normal form is explained through a different example. We have department number, MG number, and then MG, I don't know, management or something else. I think what is this representing? Then employee number and employee name. Now, instead of keeping multiple attributes in one row, what you have to do is you have to make separate entries in your table for each one of these. So now all attribute values are atomic because there are no repeating groups and no composite attributes. Then for second normal form, relation R is in second normal form if it is in first normal form, and all non-prime attributes are fully dependent on the candidate's keys. So a prime attribute appears in the candidate key as there is no partial dependency in the CNF. So now there are two non-key fields. I'm skipping this example because we have already talked about first normal form. Now, Boyce squad normal form states that a relation is in BSNF if and only if every determinant is a candidate key. The difference between TNF and BCNF is that for a functional dependency from A to B, so if it is A depending on A attribute is depending on B, 3NF allows this dependency in a relation if B is a primary key attribute. So if you are saying 3NF, it means B is a primary key attribute, so A can depend on B. And also we said that A is not a candidate key. So A is not a candidate key and B is the primary key, so every non-key attribute can depend on the primary key, depended on the primary key. If it is not, then there was a problem. So every attribute is non-key attribute is depending on the primary key. Whereas BCNF insists that for this dependency to remain in a relation, A must be a candidate key. This is the only one difference among BCNF and 3NF. BCNF, I'm repeating it, that for this dependency to remain in a relation, like A is depending on B and B is a primary key, A must be a candidate key. A is a key which is a candidate to be a primary key. So if there is a key which is candidate to be primary key, then that can depend on the primary key. So this is one condition. Now let's see this example. This is the details about client interview. This is client number CR76767456. Interview date is 13th May. Interview time is 10:30, 12, then 12, 10:30. Staff number who will be taking interview, SD5, SD5, SD37 and SD5. Okay, now you can see here that the timings or dates are different for every staff number. And the room number is G101, G101, G0102 and G102. Okay, now if we say that what is the now if we talk about client number and interview date. So this can be primary key because client number is combined with interview date is not, although it's not uniquely, if we say that it's a primary key, but it is not uniquely identifying two different entities, because if we combine as client number and interview date from here, this is not uniquely identifying your entity. And if you combine interview time, staff number and room number, then it can be a primary key. Now if we say staff number, interview date and interview time, staff number, interview date and interview time, then this is depending on client number and this is a candidate key. Similarly, if we combine make a different combination, then these are also candidate keys. And if we say staff number and interview date, then it can be staff number and interview date is also getting repeated, because SD5, the interview date SD5 and interview date for SD5 in first and second rows are same. So if they are if we talk about room number as well, that all the information is the same. It is not a primary key. So this table suffers from updation anomaly because two tuples have to be updated if the room number need to be changed for staff number SD5. So if you have to change the room number for SD5, then you need to update two tuples on, for example, if you are talking about 13th May only, then you need to update room number for first and second row. So this is the updation anomaly. To transform the client interview relation to BCNF, we must remove the violating functional dependency by creating two new relations called interview and staff room as shown below. We can make a table for interview in which client number, interview date, interview time and staff number is mentioned, and we are making a separate table for staff room where staff number, interview date and room number are mentioned. Now another BCNF example. I think before moving on to this, I should, these are the sources of these slides. Okay, before moving on to this, now I want to give you an example for your practice so that you can see that where you stand as per your understanding. This is a question I explored web and found this question which is quite suitable. So if you can solve this question and you can understand this, so let's see where you stand. Sorry, I'm pressing 7. Okay, now please focus on this. Now if you can view it properly, please raise your hand so that I can, if you can, I hope you can see it properly. Okay. Now this question is about normalization and engineering. Consultancy firm supplies temporary specialized staff to bigger companies in the country to work on their project for a certain amount of time. Right? There is an engineering consultancy company which is supplying temporary specialized staff to bigger companies in the country to work on their project for a certain amount of time. The table below lists the time spent by each of the company's employee at other company to carry out projects. The national insurance number is unique for every member of the staff. So you have an engineering consultancy firm and you have different employees, your staff who are associated with different companies, and they are working they are specialized in their work, and they are working on different projects. So this is the unique national insurance number of the employee. This is contract number, this is the hours, this is the employee name, this is the company ID, and this is the location. Now, you have to first tell that in which normal form this table is. Then you have to find the primary key for this relation and explain your choice. You can expect such type of questions in your exams as well. Then you have to find the fully functional dependencies on the primary key and partial dependency on the primary key. Normalize the table to second normal form. Find the transitive dependencies on the second normal form tables and normalize the table to third normal form. And then the last part you can omit because you have not studied so far data manipulation language. Okay, before I want you to think about it before moving on to the solution. So please spend some time, think about it, and then I'll show you its solution. So I'm giving you around 10 minutes to observe this. Try to find out that in which normal form it is. Try to find that what is the primary key of this table, and see that which of the non-key attributes are depending on the primary key. Either they are fully depending on the primary key. If they are fully depending, it is full functional dependency, and if they are partially depending, it is partial dependency. And then try to normalize it into second normal form. So if you can do it up till this part, like part E, it will be enough for me. Right now I'm giving you 10 minutes to do this, so please think about it, and you'll get, I think, the same amount of time you'll be getting in your exam. So let's omit the other parts. Okay, I'm giving you 10 minutes for this, and I'll be back after 10 minutes. Okay, students, I am back earlier than my time. So how is it going? Anybody has done part A or B? Okay. Yes, there is no, all the values are atomic, and there is no repetition, so we can say that the table is in first NNF. So then we have to define the primary key. So we define primary key. We can choose NIN and contract number as a primary key. So NIN candidate attributes are NIN, contract number, and company ID. We can choose NIN and contract number as the primary key because these two will be minimum attributes required to uniquely identify each row in the table. Also will reflect better the objective of the company, which is to keep record of staff applied to contract to another company. So it is not like we can have a primary key having NIN, insurance number, NIN, contract number, and company ID as well. But we want our primary key to be as small, as concise as possible. So that's why if we keep it only NIN and contract number, it will be sufficient. You can see here. Like if you can see here that this NIN and this INI is getting repeated, but the contract is different. So if you are combining NIN, national insurance number, and contract number, so these are unique for all. Okay, so this is the, yes, we need to divide it into multiple tables now. So first of all, we said that this table is in first normal form because there is no duplicate values in single column. Then we said that the primary key is national insurance number and contract number. Now we'll see that how dependencies are going on. So the third question we had to answer was about we have to find the fully functional dependency on the primary key and partial dependencies on the primary keys. So if we see here, now national identification number and contract number is the primary key. So national identification number is partial dependency on the primary key, contract number is partial dependency on the primary key. Now we have to examine the remaining attributes. So if we talk about hours, this is the main attribute that needs to be recorded. It is functionally dependent on the employee and the associated contract. It means it is depending on the complete primary key. Similarly, if we talk about employee name, so this is fully functionally dependent on national insurance number, but not on contract number. So because an employee can have a different contract with some other company as well, so it is partial dependency because it is depending on part of primary key. So it means there is a problem, and we need to resolve it using to make it in second formal form. Then company ID and company locations are dependent on contract number, but these are not related to national insurance number. So these are also partially dependent on the primary key. So to normalize this table to second normal form, we need to remove the partial dependencies. So now the partial dependencies are for employee name and for contract number, are for company ID and company location. So if we say here, now the dependency is on these. Now we need to resolve these dependencies. So how we resolve this? To remove the partial dependencies from the table and locate them in a new table, what we do is we make a separate table for staff contract, in which we keep national insurance number and contract number and hours. We keep the other details out of it. For example, we are keeping employee name with national insurance number of the employee, and we are keeping contract details separately with contract number, company ID, and company vacation. So in this way, now your table is in second normal form. So is it clear or not? So any question from these? Yes, this is quite useful, and you should expect a similar type of questions in your exam as well. Like you may be given a table and you may be asked to tell that in which normal form it is, and you may be asked to tell its primary key. You may be asked to tell that what are the attributes they are depending, and you may be asked to convert it into second normal form or third normal form. So I would suggest that do a lot of practice. Pick up different examples from the web. Like if you search on Google about normalization examples in databases, or you can search on Google normalization questions, normalization in databases questions, or normalization in databases exam questions. So you would be able to search a lot of questions, and yeah, they can ask questions like, for example, they give you a table and ask you to whether national insurance number is a primary key. It is a true or false. So they can ask question like this as well, or they can ask question like employee name is functionally dependent on contract number, true or false. So they can ask question like this from this table as well. But because in this midterm exams we'll be focusing on all the topics we have covered so far, so you cannot say that true false will be focusing only on this. So you can expect a short question, or even you can expect even a long question on this as well. Like the most important thing in this course is to like you should know that how you should the most important thing that each one of you should know is how to make entity relationship diagram. Because you may be given a scenario and you may be asked to make an entity relationship diagram, and the other one is to normalize this. Like because when you will be making an entity relationship diagram, you will be defining all the entities, you will be defining all their attributes, you will be naming them, you will be representing all the relationships, and when you will be representing all the relationships, you will be also be telling about the primary key, foreign keys, composite keys. So the ERD will be completely depicting the things we have studied in the last few weeks, and then you may be asked to normalize it up to second normal form or third normal form. So this can be a question like this can come because your midterm exam will be of 1 hour duration, and you can expect that there will be a one long questions of similar nature in your exam. So I would suggest that do a lot of practice about making entity relationship diagram. Pick up different scenarios and try to make entity relationship diagram, and you can see the solved examples of making entity relationship diagram as well. So if you have clear concepts about primary key, if you know what is foreign key, if you know what is composite key, and how different symbols are used in entity relationship diagram, what is cardinality, what is modality. So if you know about all these things, then there will be no problem in exam. So hopefully it will be good. And in coming week we'll have a 1 hour session. Hopefully I'll try to cover the weekly contents in a face-to-face session, and I'll dedicate our virtual session for revision. So revision all the topics we have studied so far. So meanwhile, if you find any question from the contents you studied today or in previous week, you can always ask me questions. Okay, so thank you very much. I'm turning the recording off. If you find any question, you can text me over here. Thank you very much.